Okay, so I'm doing number 15 and the chapter 10 homework. So I already do the picture. So here is like the mass of 4 kilograms, and then it's going under a constant velocity of 4.5 meters per second. And then its original position is at 3I plus 0J, so right here. And then it undergoes a displacement of 9 radians. And then so for the first question, it asks what the position vector is. And then so you do 9 radians, and you convert this to degrees, so 180 degrees over pi radians, and then you get 516 degrees, and then so you subtract 360 from this, and then you get 156. So that's like pretty much like the same position on the graph, except like you just like go one more, but subtract one less, like 2 pi radians, you know. And then, so from there, you do 3 times cosine 156 I plus 3 sine 156j, and you get negative 2.73 pi plus 1.24j meters. So that's the position for that. And then second question asks, in what direction is it moving? And wait, no. In what quadrant is the particle located, and what angle does its position vector make with the positive x-axis? And then, so, as you can see from here, this is in the second quadrant already, because since it would be negative and then positive, and that's the second quadrant. And then to find the angle, well, we already know it, it's at 1p6, so. And then for C, it asks you what is its velocity, and then so it's 4.5 meters per second at 246 degrees, and you get that from adding 90 degrees to 156, because so the original velocity is going like this, so that's at 90 degrees, and then after that, the velocity is like at this place right here, so you have to add 156, so that's why it's at 246 then. Yeah, and then so you do 4.5 cosine 156 I plus 4.5 sine 156j, and you get negative 1.85 I plus, or minus 4.1 j meters per second. And then for part D, it asks you what direction is it moving, and make a sketch of its position, velocity, and acceleration vectors. So at 156, so it's in the second quadrant, so you can say like it's out here. So this is the position vector, and then for velocity, it's at 246. That's like around here. And then if you like look here, it's so it's negative, so it's probably right here. Or wait, it's like this. And then for the acceleration vector, so it's the centripetal acceleration, so it's always pointing into the circle. So it would just be like that. And then, so it's moving towards the third quadrant, here. Yes. And then, so that takes care of part D. So part D is like over here. And then, so part E, it asks you what is its acceleration. And then, so I said A equals b squared over r, so that's 4.5. And then meters per second squared at 336, which is 156 plus 180 degrees, because it's on this side, and then so since it's pointing here, this is where the angle would be. And then, so you do 6.75 cosine 336 pi plus 6.75 sine 336j. You get 6.15 I minus 2.78 J meters per second squared. And for part F, it asks you what the total force is, and then so F equals MA. So it would just be force you have from here.
May I have your attention, please?
And then
the library is closed in 30 minutes.
and then
You have items to check out.
you multiply it by the acceleration vector.
Closed in 15 minutes. All textbooks and Chromebooks should be returned now. New library cards will not be issued after 7:45. The library will close promptly at 8 p.m.
So then you get 24.6 I minus 11.6 J newtons. So yeah, that's number 15.